Hello everyone. In my previous concept, I discussed about galvanometer and we got an expression for figure of merit. So the important application of the galvanometer is I said that it is used to measure current, a very feeble currents also it can be measured. But the problem is that an ordinary galvanometer cannot be used just like ammeter we are using to measure current. Ammeter is the instrument we are using to measure currents accurately, because ammeter itself a particular meter to exactly to measure the current. The galvanometer it just shows deflection, and on the galvanometer there are no such a kind of units. We cannot use it directly. But one thing it can be used, we can convert galvanometer in terms of ammeter, and that is also we can convert according to our needed. Suppose if this galvanometer having maximum 0 to 30 divisions, it can be converted if you want 1 to 3 amps of ammeter, or if you want it can convert from 1 to 10 amps, any range it can be converted. So two things is we need to discuss it here. The two things are why the galvanometer cannot be used directly to measure the current. The first thing is the galvanometer is a very sensitive device. Very sensitive means for a small currents it gives large deflection in the needle. So that's the first reason. So a full scale deflection for a small currents at the order of the microamperes or milliamperes. And second thing, for measuring currents, the galvanometer should connect in series in the circuit. So that is one of the very basic when it comes to circuits. To measure currents, ammeter always connect in series with the anything what we want to measure. Suppose if you want to measure the current in the circuit in the bulb, so ammeter always connected in series. But when we connect galvanometer in series, galvanometer is already having resistance, and when it comes to in series, the resistance value gets increased. Suppose if I take G is the galvanometer resistance and it is connected to bulb. So the bulb is also having resistance. The bulb is also having resistance and galvanometer is also having resistance. Now in this case what happens? The total resistance of the circuit increases. It means the bulb it won't get the proper potential difference because of the galvanometer. Because the galvanometer is having its shunt resistance, series resistance. So to convert galvanometer into voltmeter of the desired range, how much range of ammeter we want to construct. So here we use a small technique with the help of shunt resistance. What is shunt resistance? Shunt resistance. Shunt resistance, it is a very low resistance which is connected in parallel with the galvanometer. So we know that when resistance are connected in parallel, the total resistance gets less or the total resistance decreases. So if we connect a shunt resistance across the galvanometer, then the current's value decreases. How it can be done? To convert the galvanometer in terms of ammeter, first we need to take a galvanometer. Suppose if this is galvanometer, G is a galvanometer. It is like that, and a resistance is connected in parallel. to the galvanometer. Now if this resistance is connected parallel to the galvanometer, now observe carefully at here. So if I is current is passing, when it comes to a junction at here, the current gets divided. If the current which is passing from junction A, if this current if I take as galvanometer current Ig, and rest of the current which is passing through resistance is I minus Ig. So the current here divides. Yes, strong currents are not passing through galvanometer because of the parallel resistance, and when it comes to another junction at B, the same currents gets add up. Ig current will become from the galvanometer and I minus Ig come from the top of shunt resistance, and the total current I remains the same. So here what a resistance which is connected in parallel to the galvanometer, so this resistance plays a key role, and this is only called as shunt resistance. And if I take all together this entire setup, which I am going to highlight with this color, this entire setup, a parallel resistance which is a resistance which is parallel to galvanometer, so this entire thing we call as ammeter. So otherwise you can remember like this: ammeter is a galvanometer, but a parallel shunt resistance connected galvanometer is known as ammeter. Here the shunt resistance plays a key role. The uses of shunt resistance to prevent the galvanometer to damage large currents. Suppose if current is more, then the current straight is passing through galvanometer, that damages the galvanometer. But when you connect parallel resistance, so the currents divides, so that is acting just like safeguard to the galvanometer. And not only the current divides at here, the parallel resistance connection changes the galvanometer to ammeter. And not only that, by using that we can increase the range of measuring. Suppose in your hand you don't have an ammeter of the 0 to 10 volt range, but in the given circuit you need a necessary that you need to measure, you are having a necessary that you need to measure a 10 ampere current. Suppose if you are having any galvanometer with you, we can convert that. Suppose if I write the things at here, if G equal to resistance of galvanometer, and Ig is current in the galvanometer, and S is the shunt resistance, is equal to shunt resistance, and I minus Ig is the current through the shunt. I minus Ig is the current through the shunt. Now if you can apply the potential difference, if you can measure the potential difference across the galvanometer and shunt resistance, since they both are in parallel, so the potential difference across the galvanometer equal to potential difference across the shunt. Since they are parallel, so the potential difference across galvanometer equal to the potential difference across shunt. Yeah, this thing we know that, because when resistance are connected in parallel, so the potential difference remains constant across the two resistors. So these things happens in any parallel combination. So the potential difference across G stands at here galvanometer equal to the potential difference across shunt. Now we know the resistance and currents. So Ig is current in the galvanometer and G is the resistance of the galvanometer, which is equal to I minus Ig is the current across the shunt resistance, and R I have taken here S is the shunt resistance. S is the shunt resistance. So this I have written from Ohm's law, V equal to IR. We need to write the potential difference. So Ig is galvanometer current and G is galvanometer resistance, and I minus Ig is current across the shunt resistance, and S itself is the shunt resistance. And here if you can write the expression for shunt S equal to Ig times G upon I minus Ig. Now ask a question. To convert galvanometer in terms of ammeter, how much shunt resistance we need to connect? So we need a certain value, maybe 10 ohms or 20 ohms or 30 ohms. How much shunt resistance we need to connect? So the formula for the shunt resistance S here, we got it that S equal to Ig times G upon I minus Ig. So by connecting a shunt resistance S across the galvanometer, so we can convert that galvanometers in terms of an ammeter of desired range. So this is the amount of the shunt resistance we need to convert. For that we need to find the G. What is the galvanometer resistance? Yeah, here how do you find G? Here G is galvanometer resistance. So galvanometer resistance is also having one more term, that is nothing but figure of merit. It is figure of merit. What is the figure of merit formula? Figure of merit G equal to I upon alpha, which is also equal to K upon NBA. Yeah, before to calculate shunt resistance, you should know what is the resistance of the galvanometer. If you do not know the figure of merit or the resistance of the galvanometer, so then things gets complicated. So finally I can make a comment at here, how much resistance should connect to a galvanometer to convert in an ammeter of desired range. So we should know the figure of merit of that particular galvanometer. So as a conclusion of this concept, if I can say, what is an ammeter? An ammeter is a shunted or low resistance galvanometer. An ammeter is a shunted or low resistance galvanometer. Yeah, so this is the concept how we convert galvanometer into ammeter. So not only galvanometer can be converted into ammeter, the galvanometer can also be converted into voltmeter. We know the voltmeter. Voltmeter is used to measure the potential difference across the given circuit. So with the help of the voltmeter, we can measure what is the potential difference in the given circuit. Suppose if you have galvanometer, so that galvanometer can be converted into voltmeter. Yeah, your guess is correct by using again resistance, the same resistance. Now this time that resistance is connected in series. So if G is the galvanometer resistance, and if we add here extra a series resistance to galvanometer, and this total setup will becomes a voltmeter. So this total entire setup is a voltmeter. If I is current is passing, the same current will passes through the galvanometer and through the resistance. So how it can be converted? Let us take the same. Now, if I suffix G is the current in the galvanometer, I suffix G is the galvanometer current, we need to find that what is the resistance here supposed to be add. Okay, now for that, what is the total resistance? Total resistance equal to galvanometer resistance plus series resistance, which is R. Yeah. Now to find the current Ig by using Ohm's law, we can write upon V upon G plus R. Here the G plus R is the galvanometer resistance plus series resistance. So from this expression, if we can write that I need to find what is the value of R. So R plus G equal to V upon Ig. I suffix G. Now here we can do some exchange the terms. R equal to V upon Ig minus here G. So here I am asking a question. I am having a galvanometer, but I need to convert the galvanometer in terms of voltmeter. Yeah, I need to do one thing is that I need to add a series resistance to that galvanometer. But what is that amount of series resistance? Here R, what is that? How much series resistance we need to add? The series resistance it's supposed to be add. It is depend upon how you want to convert that galvanometer in terms of the voltage. It means, suppose I want to convert a galvanometer in terms of 0 to 3 volt. Yeah, here in the place of V you need to substitute 3. Or you want to convert a galvanometer in terms of 0 to 25 volt. So in that case, your voltmeter range equal to 25. So two things we need to know. One is at what range of the voltmeter you are going to convert. According to that, the series resistance value will changes. And moreover, very important thing is that here G is again known as galvanometer resistance or figure of merit. To convert galvanometer in terms of an voltmeter of desired range. Desired range means at what range you want to convert that. Two things. You should know that the one thing, at what is the range of the volt I need to convert. The second thing is that particular galvanometer resistance, or the galvanometer figure of merit. Figure of merit is very, very important. So without knowing that particular galvanometer figure of merit, so we cannot able to convert. So again I will give a reminder at here how you can figure of merit by using formula figure of merit. G equal to I upon alpha, which is also equal to K upon N BA. Or when it comes to experiment, we will use different techniques. So that techniques which enables us to find the galvanometer resistance. So finally here I can make a conclusion statement. What is a voltmeter? A voltmeter is a high resistance galvanometer. A voltmeter is high resistance galvanometer. Why the word high has come at here? I hope you can guess that, because we connected a resistance in series to the galvanometer. Yeah, when we connect resistance in series, what happens? The total resistance value is increases. So finally and commonly, the three meters, galvanometer and voltmeter and ammeter. So these three are the common meters which we use for the different purpose in the experiments. But they both are having common thing is that is galvanometer resistance. An ammeter is a parallel or shunt resisted galvanometer or low resistance galvanometer, and a voltmeter is a high resistance galvanometer. This is all about conversion of galvanometers into desired ammeter and voltmeter.